So an equation, just to remind you, is an equality between two polynomial expressions. Right now, the worst we're going to see is with one variable and some constants. Now, I just remind you, our goal here is to get the variable term by itself. Well, you see there are two variable terms. So the first goal that I always want you to think about is get those variables together, in this case the x terms. So the best bet for doing this is to look at the coefficients on each of the x terms and say which one is the more positive of the two. Now, despite the fact 3 is a bigger number, it's negative 3. So you're going to try and bring it over to here where you have a leading term or a variable term that's 1x, which is bigger. Now, how do I get that 3x out of here? You're going to use balancing, and basically that means adding the opposite to both sides. Remember, these are 4 terms, and I want to move or get rid of the negative 3x term. I'm going to add 3x to this side. And the cardinal rule of equations is whatever you do to one side, you have to do to the other. So I'm going to add 3x to this side. Now, I could line it up if I wanted to, but basically, you're just going to simplify this cluster of terms. On the right, well, we wanted this to work out so that the 3x's would disappear, and that's exactly what's going to happen. And all I'm going to be left is with the constant. On the left side, I've got a couple of x terms that are going to combine together. Notice, by the way, it's a positive 3x, right? It's the opposite of what was on that side. So putting it together, I'm going to get 4x and just the constant term floating around. So I've got a slightly simpler version of the equation. Now, I still want to isolate the variable term. So I've got to get rid of this minus 5. It's not helping me. In fact, I don't want to know what 4x minus 5 is. I want to know what 4x is and eventually what x is. So, same way as I got rid of the negative 3x, I'm going to get rid of the negative 5 by giving a positive 5 on this side. And, again, balancing. Remember, this is like a barrier that splits them. Positive 5 on this side, positive 5 on that side to keep it balanced. When you simplify this, you're going to get 4x. On the right side, you're going to get 17. Getting there, I got the variable term by itself, and the last part is to get the variable completely on its own. We call that isolate the variable after. And so I say to myself, what is preventing the x from being by itself? Well, there's a multiplier. All of those other guys were adding or subtracting terms, but now this is a term and I want to remove the coefficient. It's a multiplication. So I do that by dividing by the coefficient of the variable. In this case, that means dividing by 4. If that was a fraction, you would multiply by its reciprocal, and whatever you do to one side, you do to both sides. So this, they would cancel out, leaving me with x equals 17 over 4. What an ugly answer. But it doesn't matter. It depends what I need this for. If I was talking about money, I might want to change this to a decimal with a couple of decimal places, something like 4.25. However, you've solved the equation and then you figure out what you have to do with it.